Okay, let's look at definite integrals, right? So here's the definition, right? So definition of definite integral, so it's an integral from a to b, right? So the difference is you have this number here. This number is called lower limit. All right, and of course the top number is called the upper limit. All right, then you have a function, and just like before, this is integrand, this is differential. All right, so it's defined to be the limit of the Riemann sum. All right, Riemann sum is just the approximation of the area, something like this. All right, so it looks like this. And top bound is the graph of the function f of x. So this guy is the f of x. All right. Then since Riemann sum is an approximation, but if you use a extremely large n, which means that you're using many rectangles like this. So you have a lot of approximating rectangles. So as the number of n, or number of rectangles increases, the approximation gets better and better, and eventually becomes the actual area that you're looking for, right? So that's kind of the idea. So you have a Riemann sum, which is going to be a summation. K goes from 1 to n, and f of ck times delta x. Right, this is just an approximation, but to make it as precise as we can just take the limit, say n goes to infinity, which means that the number of rectangles we're going to use is going to go to positive infinity. Right, so that's the definition of definite integral, which gives you basically the area under the curve. All right. And let's look at the next topic, which was a definite integral as a net areas. Right. So what if the function goes below the x-axis? Then what happens to the definite integral? So that's why we call definite integral as net areas. Right. So let's look at this simple example here. Right. So this is an example. All right, let's say you have a graph of f of x, which goes actually below the x-axis for some point. And then the area here is 2. Area below the x-axis 4. Area above the x-axis 3, right? What will be the value of the definite integral from a to b of f of x dx, right? So here is what happens. If you have a region above the x-axis, it counts as a positive area, right? Like these two, right? But if the region is below the x-axis, it's going to count as negative, right? So this guy, this definite integral is going to have a value of positive 2 plus negative 4 plus positive 3, which is going to be 5 minus 4, so it's going to be 1. So the area, the value of this definite integral is going to be 1, because the regions above the x-axis has a positive contribution, and the regions below the x-axis have negative contributions. Right? That's it. I hope that this was clear.